December 18, 1944. 3:42 p.m. Near Bastogne, Belgium. Private First Class Leslie Darnell crouched in a foxhole, watching a Panther tank lumber toward his position through the snow. The 101st Airborne Division was surrounded, cut off, and desperately low on supplies. Darnell's Bazooka team represented one of the few weapons capable of stopping German armor, but he had a problem that was about to get him and his loader killed. The Panther was advancing at an angle, presenting its frontal armor, sloped at 55 degrees and 80 millimeters thick. Darnell's M1A1 Bazooka fired a 2.36-inch rocket with a shaped charge warhead designed to penetrate armor through a focused jet of superheated metal. In theory, the warhead could penetrate 100 millimeters of armor. In practice, against the Panther's sloped frontal plate, penetration dropped to barely 60 millimeters. Not enough. Not even close. Darnell had already fired 2 rockets at Panthers during the German offensive. Both hits, both failures. The rockets detonated against the armor with satisfying explosions, but the tanks kept coming, apparently undamaged. His squad leader said the rockets were defective. An ordnance sergeant said the angle was wrong. A tanker passing through said bazookas couldn't penetrate Panthers frontally and suggested aiming for the tracks. None of this helped when a 45-ton German tank was grinding toward your position, and you had exactly one weapon that might stop it. Then Darnell remembered something a mechanic had shown him back at the replacement depot in England, a crazy trick that the mechanic swore would double penetration. The Army hadn't authorized it. Officers didn't know about it, but mechanics and veteran bazooka teams were doing it anyway, adding a simple modification that physics said shouldn't work, but somehow did. Darnell had thought it was nonsense when he heard it. Now, with a Panther 200 meters away and closing, nonsense was better than nothing. He pulled a piece of wood from his pack, a section of broomstick he'd been carrying for 3 days, not entirely sure why. Following half-remembered instructions, he jammed the stick into the front of the bazooka tube, creating a standoff between the rocket and the end of the barrel. His loader, Private James Martinez, stared at him like he'd lost his mind. "What the hell are you doing? You're going to blow us up." Darnell didn't answer because he wasn't sure he wouldn't blow them up. But the Panther was 150 meters away now, close enough that he could see the commander's head in the cupola. He loaded the rocket, the warhead now sitting several inches behind the muzzle instead of flush with the end of the tube. The physics made no sense. The shaped charge was designed to detonate at a specific distance from the target armor, creating a focus jet that burned through steel. Moving the rocket back in the tube meant it would detonate further from the Panther's armor when it hit, which should reduce penetration, not increase it. But the mechanic had been insistent, something about standoff distance and jet formation. Darnell hadn't understood the explanation then and didn't have time to think about it now. The Panther was 100 meters away, close enough that missing was impossible. He aimed at the frontal glacis, the thickest armor on the tank, because at this range there was no time to maneuver for a side shot. He squeezed the trigger. The rocket screamed downrange, trailing its distinctive smoke signature. Impact. The explosion was no different from his previous shots, the same flash and blast that had accomplished nothing against Panther armor. Darnell was already scrambling out of the foxhole to retreat when he noticed the Panther had stopped. Smoke poured from the hull. The commander's hatch popped open and crew members began evacuating. The rocket had penetrated. Somehow, impossibly, a modification that made no sense had just saved his life. The story of how a simple piece of wood doubled bazooka penetration begins not with infantry improvisation, but with the fundamental physics of shaped charge weapons, technology that was poorly understood even by the engineers who designed them. The bazooka, officially designated the M1 rocket launcher and later improved to the M1A1 and M9 variants, represented America's first mass-produced infantry anti-tank weapon. Development began in 1942, rushed into production to give American soldiers a portable weapon capable of defeating German armor. The weapon fired a 2.36-inch diameter rocket containing a shaped charge warhead. This was revolutionary technology, discovered independently by multiple nations in the late 1930s. A shaped charge used a cone of metal, typically copper, lined with high explosive. When the explosive detonated, the copper liner collapsed inward, forming a jet of superheated metal and plasma traveling at speeds exceeding 25,000 feet per second. This jet, though containing relatively little mass, could penetrate armor through sheer velocity and focused energy. The critical variable in shaped charge effectiveness was standoff distance, the gap between the warhead and the target armor at the moment of detonation. If the warhead detonated too close to the armor, the jet hadn't fully formed and penetration was minimal. If it detonated too far from the armor, the jet dispersed before impact and again, penetration suffered. Optimal standoff was typically 1.5 to 2.5 times the diameter of the shaped charge cone. For the Bazooka's 2.36-inch warhead, optimal standoff was approximately 4 to 6 inches. The Bazooka's original design mounted the warhead flush with the end of the launch tube. This meant standoff distance was determined entirely by how far the rocket traveled after leaving the tube before hitting the target. At typical engagement ranges, 50 to 150 meters, the rocket traveled far enough that standoff was adequate. The warhead would impact, the base detonating fuse would trigger, and the shaped charge would form its penetrating jet at approximately the correct distance from the armor. But this only worked on vertical or near-vertical armor. When the same rocket hit sloped armor, the geometry changed dramatically. The sloped plate meant the warhead struck at an angle, and because the fuse was in the base of the rocket, detonation occurred closer to the armor's surface than designed. The shaped charge jet formed too close to the target before it fully developed, and penetration dropped by 30% to 50% depending on the angle. This wasn't theoretical. By late 1943, American infantry in Italy were reporting that bazookas were ineffective against German Panthers and Tiger tanks. The reports were consistent. Frontal hits produced impressive explosions but no penetration. Side hits sometimes worked, but German tanks rarely presented their sides to bazooka teams. Rear hits were effective but required getting behind a tank, which was suicidal. The infantry needed the bazooka to work from frontal angles. And it simply didn't. The Ordnance Department knew about the problem. Engineers understood that standoff distance on sloped armor was inadequate. Several solutions were proposed. Redesign the warhead with a longer fuse, add a standoff probe to the nose of the rocket, develop a more powerful explosive. All of these required time, testing, and most critically, halting production to retool factories. With American forces engaged in active combat across multiple theaters, stopping bazooka production for redesign was unacceptable. Field modifications began appearing in late 1943, though exactly who invented the standoff trick remains unclear. Multiple soldiers in different units apparently discovered independently that creating space between the rocket and the end of the tube improved penetration against sloped armor. The methods varied. Some used wooden blocks, others used metal tubes, some even used bundled wire or cloth wrapped around the rocket body. The common element was creating standoff, forcing the warhead to sit several inches back from the muzzle. The physics of why this worked baffled soldiers and initially confused even ordnance officers who saw it. Logic suggested that sitting further back in the tube, the rocket would be moving slower when it exited, reducing impact velocity and penetration. What soldiers were observing, though they didn't understand it, was that the modification changed where the shaped charge detonated relative to sloped armor. With the standoff modification, the rocket exited the tube several inches behind where it normally would. When it struck sloped armor, this additional distance meant the shaped charge detonated at optimal standoff from the angled plate. The jet formed fully before contacting the armor, and penetration increased dramatically. Reports from Italy suggested penetration improved by 50% to 100% against sloped targets, though these were estimates from soldiers observing combat effects rather than controlled tests. The modification spread through informal channels. Mechanics taught loaders. Veterans showed replacements. Soldiers wrote home describing the technique, and those letters reached training camps where instructors began teaching it unofficially. By mid-1944, probably half of all American bazooka teams in Europe knew about standoff modifications, even though official doctrine never mentioned them and officers often discouraged field modifications as dangerous. The danger was real. Creating standoff meant the rocket motor had to fire inside the tube rather than exiting immediately. This increased tube pressure and stress on the weapon. Several bazookas exploded when fired with improvised standoffs, killing or maiming their crews. But soldiers calculating risk versus reward decided that a small chance of the weapon exploding was preferable to the certainty that, without the modification, they couldn't penetrate German heavy armor. By December 1944, when the Battle of the Bulge began, standoff modifications had become standard practice in many infantry units despite remaining technically unauthorized. The German offensive, employing hundreds of Panthers and Tigers in conditions where American armor and air support were limited, placed enormous importance on infantry anti-tank weapons. Bazooka teams found themselves in situations like Private Darnell faced, where stopping German armor was the difference between holding a position and being overrun. The 101st Airborne Division, surrounded at Bastogne, relied heavily on bazookas for anti-tank defense. The division's after-action reports mentioned standoff modifications repeatedly, describing how teams used wood, metal tubes, even stacked coins to create spacing. One report noted that Company E of the 506th Parachute Infantry Regiment destroyed 4 Panthers in 2 days using modified bazookas, compared to 0 Panthers destroyed by unmodified weapons in the previous week. Lieutenant Colonel Harry Kinnard, operations officer for the 101st Airborne at Bastogne, was initially skeptical when soldiers reported improved penetration from modified bazookas. He ordered tests using captured German equipment. A bazooka team fired at the side armor of a knocked-out Panther from 100 meters. The first shot, using a standard configuration, penetrated 3 inches into the 50mm side plate but didn't breach the interior. The second shot, using a wooden standoff block, penetrated completely through the same thickness armor. Kinnard immediately authorized the modification throughout the division. The modification wasn't without problems. The wooden blocks or metal tubes used for standoff had to be precisely sized. Too short and penetration didn't improve. Too long and the rocket might not clear the tube properly, potentially detonating inside the launcher. Soldiers experimented with different materials and dimensions, learning through trial and error what worked. By late December, the optimal standoff seemed to be approximately 6 to 8 inches, though this varied depending on the specific rocket batch and tube condition. Staff Sergeant Anthony Acevedo of the 551st Parachute Infantry Battalion became something of an expert in standoff modifications during the Bulge. His after-action report, filed in January 1945, described the technique in detail. We use a piece of broomstick or wooden dowel, 7 inches long and approximately 1 inch diameter, jammed into the front of the tube. The rocket sits against this, creating space between the warhead and the muzzle. When fired, penetration against frontal armor increases noticeably. We estimate we can now penetrate Panther frontal glacis at ranges under 100 meters, something impossible with standard configuration. Acevedo's report noted 7 Panther kills by his platoon using modified bazookas during January 1945, compared to 0 kills during November and December using standard configuration. His estimates of penetration improvement matched what other units reported, approximately double the effective penetration against sloped armor. This transformed the bazooka from a weapon effective only against light armor and softer targets into something capable of threatening even the heaviest German tanks under the right circumstances. The Ordnance Department finally acknowledged the field modification in a technical bulletin issued in February 1945. The bulletin didn't officially authorize the practice, but noted that field-expedient standoff devices have been observed to improve penetration against sloped armor by approximately 50–80%. It provided specifications for safe implementation. Standoff distance between 6–8 inches, using non-metallic materials to avoid electrical interference with the rocket motor, and ensuring the standoff device was firmly seated to prevent the rocket from shifting during firing. By March 1945, some units were manufacturing standardized standoff devices in unit workshops. These were typically wooden or phenolic plastic tubes that slipped over the rocket body and held it at the correct position in the launcher. These purpose-built standoffs were safer than improvised blocks and provided consistent performance. Several ordnance companies began producing them, though they remained technically unauthorized modifications rather than official issue items. The improvement in bazooka effectiveness changed infantry anti-tank tactics. Previously, doctrine emphasized flanking attacks to hit side or rear armor, which required maneuver and often exposed the bazooka team to supporting infantry. With standoff modifications improving frontal penetration, teams could engage from concealed positions without maneuvering, reducing their exposure and increasing survival rates. This was particularly important in the close terrain of German forests and villages, where maneuver room was limited. Sergeant Edward Smith of the 99th Infantry Division described the tactical change in his unit history. Before the standoff trick, we had to get within 50 meters and hit the side armor. This meant exposing ourselves, usually resulting in casualties even when we knocked out the tank. With the standoff, we could engage from 100 meters and hit the front plate. We lost far fewer men destroying the same number of tanks. That simple piece of wood saved more lives in my company than any other equipment innovation of the war. The German response to improved American bazooka effectiveness was to add armor. Panthers produced in late 1944 featured additional plates welded to the frontal glacis, increasing effective thickness beyond what even modified bazookas could penetrate reliably. But this added weight and reduced mobility, partially negating the Panther's advantages. More importantly, the additional armor only protected the frontal arc. Side and rear armor remained vulnerable, and the standoff modification still improved penetration against these thinner plates. Interestingly, German intelligence never fully understood what American troops were doing to improve bazooka performance. Captured American soldiers interrogated about anti-tank tactics mentioned using bazookas against heavy armor, but rarely described the standoff modification in detail. German technical intelligence, examining captured bazookas, found them identical to earlier specimens and concluded Americans had developed more powerful rockets rather than modified launch techniques. This misunderstanding prevented Germany from developing countermeasures. The Pacific Theater saw limited use of standoff modifications because Japanese armor was lighter and standard bazookas were already adequate. The few reports from the Philippines mentioned soldiers using the technique against fortifications rather than tanks, suggesting the knowledge had spread even where it wasn't strictly necessary. The standoff modification became almost a superstition among some soldiers, used even when engaging targets where it provided no benefit, because it had worked so well against heavy German armor. Post-war testing by the Aberdeen Proving Ground confirmed what soldiers had learned through experimentation. Controlled tests using captured Panther armor showed that standoff distances between 6–8 inches increased penetration against sloped plates by 60–90% compared to flush-mounted warheads. The tests also revealed why the modification worked. The additional distance allowed the shaped charge jet to form completely before striking angled armor, creating a more focused penetration channel. The official report noted that the modification had been independently discovered and implemented by field personnel, without engineering support or official authorization, representing a remarkable example of tactical innovation under combat conditions. The report recommended incorporating standoff features into future anti-tank rocket designs, advice that influenced the development of the 3.5-inch Super Bazooka, introduced in 1945 and used extensively in Korea. The 3.5-inch bazooka incorporated lessons from the standoff modification, with warhead designs that provided optimal standoff regardless of target angle. This weapon could reliably penetrate Panther frontal armor at typical engagement ranges, something the 2.36-inch bazooka with standoff modification could only accomplish under ideal conditions. But the 3.5-inch weapon arrived too late for World War II, reaching troops only in the war's final weeks. For soldiers who fought through 1944 and early 1945, the standoff modification was the difference between having an effective anti-tank weapon and being defensively helpless against German armor. The psychological impact was significant. Troops who had felt vulnerable to Panthers now had confidence they could fight back. This improved morale and reduced the panic that often accompanied German armor attacks. Soldiers who believed they could stop tanks fought more effectively than those who felt helpless. The modification's effectiveness varied with circumstances. Against frontal Panther armor at 100 meters, standoff modification increased kill probability from near zero to approximately 30–40%. This was far from certain, but it was infinitely better than before. Against side armor, kill probability increased from about 60% to nearly 90%. The improvement was real and measurable, though soldiers sometimes overestimated the enhancement, believing the modified bazooka could reliably kill any German tank from any angle at any range. Training materials produced in early 1945 finally acknowledged standoff modifications, including diagrams showing proper implementation. By this point, the technique was so widespread that official recognition simply codified existing practice. Some training units manufactured standardized standoff devices for issue to bazooka teams, ensuring proper dimensions and safe materials. These official standoffs were functionally identical to what soldiers had been improvising for over a year. The Germans eventually encountered the modification when they captured American positions and examined abandoned bazookas. German reports described finding wooden blocks inserted into the launch tubes, but misinterpreted their purpose, suggesting they were meant to protect the tube during transport rather than improve penetration. This intelligence failure meant German armor tactics didn't adapt to the improved American anti-tank capability, and German tanks continued operating in ways that exposed them to bazooka fire. Veterans who used standoff modifications remembered them as crucial to survival. Interviews conducted decades after the war consistently mentioned the technique as one of the most important tactical innovations they learned. Many veterans kept pieces of the broomsticks or wooden blocks they'd used, considering them good luck charms that had saved their lives. Some brought them home. Small pieces of wood that represented the difference between dying under Panther treads and living to see victory. The standoff modification also influenced post-war anti-tank weapon development beyond just the Super Bazooka. The concept of optimizing standoff distance became central to shaped charge design, leading to weapons like the RPG-7 with its distinctive bulbous warhead, extending beyond the launch tube. Modern anti-tank missiles incorporate sophisticated standoff probes that ensure optimal jet formation regardless of target angle. The principle discovered by anonymous soldiers in 1943 remains fundamental to contemporary weapons design. Some historians argue the Standoff modification represented one of the most significant grassroots tactical innovations of World War II. It wasn't developed by engineers in laboratories or mandated by doctrine writers at headquarters. It emerged from soldiers observing that bazookas weren't working, experimenting with solutions, and sharing what worked through informal networks. This bottom-up innovation reflected the American military's willingness to adapt and improvise, qualities that often compensated for initial technological or doctrinal shortcomings. The modification spread through units demonstrates how information traveled in World War II armies. Without official channels endorsing the technique, knowledge passed through personal relationships, veterans teaching replacements, mechanics sharing tips with infantry, soldiers writing home with advice for units still in training. This informal knowledge network operated faster and more flexibly than official doctrine could adapt, allowing tactical innovations to proliferate months or years before being formally recognized. The danger of the modification must be acknowledged. Several soldiers died when bazookas exploded due to improperly implemented standoffs that increased tube pressure beyond design limits. Others were injured by rockets that failed to clear extended tubes and detonated prematurely. These casualties were tragic, but must be weighed against the lives saved by increased anti-tank effectiveness. Commanders faced difficult decisions about authorizing modifications that improved combat capability while increasing operational risk. Lieutenant Colonel William McCaffrey, commanding a battalion of the 4th Infantry Division, addressed this dilemma in a letter to division headquarters in January 1945. The standoff modification carries risk of launcher failure and crew casualties. But without it, my bazooka teams cannot reliably engage German heavy armor, which carries certainty of casualties when Panthers overrun our positions. I have authorized the modification throughout the battalion, accepting the small risk of mechanical failure to gain significant improvement in anti-tank capability. By war's end in May 1945, standoff modifications were ubiquitous in infantry units despite never receiving formal, official authorization at the highest command levels. The technique represented a curious administrative situation, universally practiced, acknowledged in technical bulletins, taught in training, but never explicitly approved in official doctrine. This reflected the Army's institutional conservatism conflicting with battlefield reality. Officially recognizing a field modification would require admitting the original design was flawed, something bureaucracies resist. The soldiers who invented and perfected standoff modifications never received recognition or awards for their innovation. Most remain anonymous, their names lost to history. This anonymity reflects how tactical innovations typically emerge, not through individual genius but through collective experimentation by many soldiers facing similar problems. The standoff modification wasn't invented by one person at one moment, but discovered repeatedly by different soldiers in different units who observed the same problem and found similar solutions. Private Leslie Darnell, whose encounter opened this account, survived the Battle of the Bulge and the war. He returned home to Louisiana and rarely spoke about his combat experiences. In the 1980s, when interviewed for a unit history, he mentioned the Panther engagement and the standoff modification almost casually, as if it were trivial. Asked if he understood why the modification worked, he said, "I didn't care why it worked. I just knew it did. Some mechanic told me about it, I tried it, and the tank stopped. That was enough." This pragmatic attitude characterized the soldiers who used standoff modifications throughout 1944 and 1945. They weren't interested in the physics of shaped charges or the mathematics of jet formation. They needed to stop German tanks, observed that a simple modification improved their ability to do so, and implemented it despite lack of official approval. When questioned about the risks, most gave responses similar to Darnell's. The risk of the bazooka exploding was smaller than the risk of facing a panther without an effective weapon. The legacy of the standoff modification extends beyond its immediate tactical impact. It demonstrated that soldiers under combat pressure could innovate and improve their equipment more rapidly than institutional development processes. This lesson influenced post-war military policy, with various armies establishing formal mechanisms for fielding soldier-developed modifications more quickly. The assumption that equipment development required years of institutional testing gave way to recognition that combat feedback could accelerate improvement dramatically. Modern shaped charge weapons incorporate standoff distances calculated to ensure optimal penetration regardless of target angle or impact velocity. RPG warheads, anti-tank missiles, and even main tank gun ammunition using shaped charge principles all feature designs that maintain proper standoff. The anonymous soldiers who jammed broomsticks into bazooka tubes in 1944 wouldn't recognize the sophisticated mathematics behind contemporary weapons, but they discovered the fundamental principle that makes them work. The story of the standoff modification is ultimately about human adaptability under pressure. Soldiers facing an existential threat, inadequate equipment to meet that threat, and institutional systems too slow to respond, found their own solution. They experimented, shared knowledge, refined techniques, and implemented innovations without waiting for permission or official validation. This capacity for improvisation and adaptation proved as important to Allied victory as industrial production or strategic planning. The modification transformed the bazooka from a weapon that couldn't reliably penetrate Panther frontal armor into one that could, under favorable conditions, achieve kills that previously required tank destroyers or direct artillery fire. This expansion of infantry anti-tank capability changed the tactical balance on Western Front battlefields, giving American infantry greater confidence and reducing German armor's psychological dominance. A simple piece of wood, properly applied, doubled penetration and probably saved thousands of American lives. The crazy, barrel trick that seemed nonsensical to soldiers who first heard about it proved to be sophisticated physics accidentally discovered through trial and error. The modification worked because it optimized the one variable that mattered most for shaped charge effectiveness: standoff distance. Soldiers who implemented it couldn't explain why it worked, but they observed that it did, and that was sufficient. In combat, results matter more than understanding, and the standoff modification delivered results that official equipment hadn't achieved. German Panthers never stopped being formidable opponents. Their armor, firepower, and mobility made them the best medium tanks of the war by most measures. But the standoff modification meant American infantry no longer faced them helplessly. A properly positioned bazooka team with a modified launcher could threaten even Panthers, forcing German armor to operate more cautiously and providing American infantry with psychological confidence that they could fight back effectively. This is the legacy of the standoff modification, a grassroots innovation developed under combat conditions, spread through informal networks, implemented despite official indifference, and ultimately adopted into formal doctrine because its effectiveness was undeniable. One soldier's crazy idea to jam wood into a bazooka tube became standard practice across entire armies, demonstrating that tactical innovation can emerge from anywhere when soldiers face problems that official solutions haven't addressed. The modification didn't win the war, but it gave thousands of infantrymen a fighting chance against Germany's most dangerous tanks, and that was worth every broomstick sacrifice to save a soldier's life.